So, hello, my name is Syimyk, and our topic is comprehensive overview in English. It's Critical University, it's Department Computer Engineering. Its first topic is about IoT. As I told you before, it's our videos here, and nice times if we can say. So the Internet of Things our refers to IoTs, our physical devices connected to Internet, capable of collecting, sharing, the processing data. So processing range for everywhere objects like home applications, so industrial machines and all equipment with sensor software communicated technologies so enable interact. So the premise goals and of iOS creates a smart systems and noise efficient saves the resource provided through expressive and automated processing and examples. Uh, so without internet that works, I would say our example. So examples of applications: smart homes, the control lights, hidden the door, and the surveillance the cameras, and the healthcare, the wearables, health monitors, our emerald everywhere, and agrees to the monitor sensors, IoT automated innovation system, and uh, transmission, the transportation, so our smart traffic, so our light in the autonomous verification, so industry, the critical machines, so our requirements, real time, the source change management. So the architecture where so is IoT architecture, the multi-layer system that facilities interact and coordinates so complex collection persistent that transmits so analyze data and the key components IoT devices sensors a layer in the physical devices in it. So interact with our environment collect data temperature and movement of the performs actions internet and light is on off and the example the temperature sensors the DHT11 cameras, black walls, and temperaments. So actuated devices so executed the commands found gates. So we can use data transmissions over here and this is a network layer. So network responsible they are transmitting the data to processing systems that are technologies, internet, Wi-Fi, Bluetooth, Zigbee, and 5G, and the processor MG, HTTP, and SCO apps, web sockets everywhere in the use IO. Data processing, the processing layers everywhere, data analysis and process this can be happen local and edge communicates internet server fax our computer and everywhere fax and computer use they call computing the application layers he's using the layers to provide integration for mobile apps web dashboards as a voice assistant example many homes and lighting cover everywhere as a mobile app so um, layers, IoT architectures, physical layers, perfection layers, performance collecting data for the sensor examples, the cumulative sensors, the alert and system when layers drop and uh, drops below the threshold, the network layers transfer data devices, processing Zigbee and Wi-Fi and your IoT, processing layers handle data analysis and decisions making including server, microcontroller, cloud platforms, examples smart thermostats detect the room temperature, the activities it hears. Applications layer and applications layer oh, provide user interfaces of devices management and to interface about this web platform we can use everywhere and IoT and data processing applications and IoT data processing um, data processing cloud company in the data center cloud centrally the processing the analysis additions and drawbacks, high latencies and internet dependency, and for communicating and data processing local before NIAID sends a cloud. Advances in the risk latency and cloud and reversal usage that it's committed cover here. So more popular is here. So I can use in everywhere I do Arduino. So offer tables is some easy platform for beginners right now. So for me, for students, for scholarships, as everywhere. So easy can use. And this one's our start, the beginner, our use IoT systems and. Say to perform small-scale project like in single sensors the data collections. And second, the Raspberry Pi. And the Raspberry Pi full features a mini computer with an operation system. So it does a complex project like video and superbands and multi-devices management. So and last time Intel Galileo and ASP and 8266 and ASP uh, 32 low cost and a Wi-Fi and LTE modules lively use a smart home and applications everywhere. So that's so and next time the Intel Galileo. So Intel Galileo and this time Intel Galileo designed for professional IoT development. Challenges with IoT data security and next time. So data security, our clouds here everywhere. Um, subtly cloud analyst community. So it's I can tell you IoT devices are vulnerable to cyber attacks and hacking for process everywhere and scalability managing large numbers of devices have a energy effectively scalability managing large numbers of devices and processing massive data volumes can be challenging and energy effectively many devices really batteries and needed energy usage. So devices compatible different manufacturers use varying standards, protocols, making the intelligence difficult. So and some challenges higher in losses in IoT. So sensors are created devices. So architecture is here. So and sensor actuator, the devices over here, over everywhere. So camera and network everywhere, so we can use and created sensors devices. Sensors everywhere, so our cars and bolt and everywhere we can use and uh, ever use sensors. So, and data creation systems, so our data creation system, our here as it says, our validated. So, in save it and so analysis where predator search analysis. So, see processing can analyze the edge analysis so everywhere so it's here. So, with the data, so analysis here. Cloud analysis and this cloud analysis, it has a server. So it's here is the cloud, it's cloud sub analysis. Everywhere is correct, it's correct. So it's shared with our computers here. So next time I can talk about ecosystem, application layer, network layers, and partition layers. So application layer is responsible for developed applications, basically servers and users, and definition application which internet things can be deployed. So network layers are responsible to connect to smart things, network devices, server also use it everywhere, and science and gather further about an improvement sensor scale and physical impairment evaluation of the objects in every environment. Basic architectures ecosystem IoT. Business layer, application layer, processing layer, transport layer, and responsive layer. So, business layers are manages our IoT system, including operating systems, and pilot models, and other privacy. Uh, so you can profit models is here. You can use in navigation, analysis, everywhere here as a business layers. Responsible for every developing application-specific service to users. So users developing application and specific service and users. Processing systems store analysis and huge amount data employs data cloud and big data processing models. Our data processors here. Transport layers transport sensors between different layers in network, such wearable 3G, LAN, Bluetooth, server, NFC, and ever NFC and paying everywhere the transport layers. So perception layers sensor sense and gather information about environment. Environment everywhere, environment here. So, IoT for computing IoT monitor pre-process, temperature store, security everywhere, security told you, told taxonomy as data, so analysis, pre-processing, build smart devices, mobile chaining, network conditions make communicate difficult. So, and cloud data centers analysis here, and smart gateways, our smart devices, our communicate with him, with Sam, so, okay. Communicate the challenges which need to address it everywhere. So and networks, so smart objects, low technologies, Bluetooth low energy, so everywhere. Zigbee protocol, so replicate layers, so are connected with communicated with him. So lowered communicate between devices needs the power the cause and the routing protocols, the memory requirement, and the communicate protocols are high speed and allows us to communicate everywhere. So, and IoT systems everywhere communicate middleware. Application, so application, pure energy, concentration, our smart social life, and smart agriculture, and home automated smart environment, health, fitness, everywhere. So we can use an application so everywhere, social instruments, so this connected, communicates its applications here. So, and that's other we can say IoT the revolution various aspects of life from personal and conversion industrial effectively agriculture consists of our devices that process communicated networks users interfaces and a better creating a smart, spaceable, and effective system. You can use in presentation with a specific example demonstration our here devices. So that's all.